Hi guys, welcome back. In this video, I'll be explaining determinants of 2 by 2 matrices and how you can find the determinant of 2 by 2 matrices. Determinant is the value that can be computed from the element of a square matrix, and determinant of a matrix A is denoted by this or that A. You understand? Like I've said, a single value that can be computed from the element of a square matrix. In essence, you can only find the determinant of a square matrix. If your matrix is not a square matrix, you cannot find the determinant. So that is, you can find the determinant of 2 by 2 matrices, 3 by 3 matrices, 4 by 4 matrices, and in general, if the number of rows of a matrix is equal to the number of columns of a matrix, you can find the determinant. So how do you now find the determinant of a 2 by 2 matrices? Let's say I have my matrix to be my matrix A, let's say is equal to 1 1, A11, A12, A21, A22. I hope you understand. Then my determinant of A, which is also denoted by this, will now be A11, A12, A21, A22. So what you are going to do is to multiply the element in the leading diagonal. You know, this is the element in the leading diagonal. You multiply it together. So that will be A11, A22, the minus element in the second diagonal. So that is what A12, A21. So like I've explained in my first video, so this is the leading diagonal. So and this is the second diagonal. So don't forget, you multiply the element in the leading diagonal minus the element in the what? In the main diagonal. If that is clear, let me give you an example so that you can understand it very well. Example, if m is what? 2, 4, 3, 8, and my n is equal to -5 minus 1, 4, 2. Find the determinant. Find number 1, determinant of A, determinant of n, and determinant of m by n. So determinant of n, m and n. Okay, now, so the first question, I have the determinant of what? The determinant of m, that's going to be 2, 4, 3, 8. Recall I told you if you want to find determinant, just multiply the elements along the leading diagonal. That will be 2 times 8, which is 16, minus the elements in the second diagonal. That's 4 times 3, which is 12. So I'm going to have 4. So likewise, so the second question, determinant of n, then I'm going to have -5 minus 1, 4, 2. So then you multiply the element along the leading diagonal. So that's going to give me what? -5 times 2, that is -10. Then plus -1 times 4, that is -4. That will give you -10 minus 4, which is equal to -14. As you can see, it is very simple. So it is very simple. No, I made a mistake. So it will be -10 minus, don't forget, minus, this will be plus, and this will now be -6. So that's that. If that is cleared, then the third one, what will now be the determinant of m plus the variable? So we knew that determinant of m is 4, then plus determinant of n is -6. So 4 minus 6 is going to give me -2. You can see it is very simple. So if you want to obtain the determinant of 2 by 2 matrix, so just what? Multiply the element along the leading diagonal minus the element along the second diagonal. So if that is clear, there is another term we use in the determinant of matrix. So we call a singular what? A singular matrix. So in your exam, you may be asked what is a singular matrix, or you may be asked to show that a matrix is what? It's a singular matrix. When we say a singular matrix, a matrix said to be singular when the determinant of such a matrix is what? Is equal to 0. So let's say if determinant of a matrix A is equal to 0, then matrix A is what? Is singular. You understand now? So you ask to show that a matrix is singular, then you have to show that when you take the determinant, you are going to have it to be what? So you are going to have it to be 0. You are going to have it to be 0. Okay, now let me give you an example. Show that A matrix A minus 2, 3, minus 6, 9 is a singular matrix. So it is a singular matrix. So how do you know that a matrix is singular? So that is when you find the determinant of A solution. If our determinant of A is what? Or that A is equal to 0, then we can conclude adequately that A is what? Is a singular matrix. Okay, let us try that. So determinant of A, what is my A? I have minus 2, 3, minus 6, 9. And how do you find the determinant? You multiply element along the leading diagonal. So minus 2 times 9, that will give you minus 18, minus the one at the second diagonal. So that's minus 18 as well. Then you are going to have minus 18 plus 18, which is equal to 0. Then you conclude by saying hence, hence A is what? A is singular since that A is equal to 0. So in essence, when you're asked to show that a matrix is a singular matrix, then just find the determinant, and if you are able to see that determinant of such a matrix is what? Is 0. So then you can conclude adequately that that matrix is what? Is singular. Let me give you another example. Example. I think this is more like a WAEC question. Yeah. So, example, if M is equal to, your matrix M is equal to minus 8, 6, minus 9, 7, and your N, matrix N is what? 5, 4, minus 10, minus 8. Then you ask to show that determinant of M is what? Determinant of M transpose. You have to note that. So when you take the determinant of a square matrix, it's also the same thing as determinant of its transpose matrix. And that's one of the beauty we have in transpose. Please take note of that. Okay, let us see whether we are going to have it. So your M is minus 8, 6, minus 9, 7. So determinant of M is going to be what? Minus 8, 6, minus 9, 7. So then don't forget you multiply the element along the leading diagonal minus those along the second diagonal. So minus 8 times 7. So that's going to give me minus 56 minus. So what is 9 times 6? So that will give me minus 54. Then I'm going to have minus 56 plus 54. That's going to give me minus 2. So that's going to give me minus 2. I hope you understand. So yeah, then if that is cleared, then we can also find what? Determinant of M transpose, but you cannot find determinant of M transpose unless you what? So unless you find the transpose of M. Okay, let me find M transpose, then after it I can find determinant of what? Determinant of M transpose. So determinant, the transpose of M, don't forget you are going to interact the row with columns. So then I'm going to have minus 8, minus 9, 6, 7. If you don't understand what I mean by transpose, refer to my video on transpose of a matrix. So Then determinant of M transpose will now be what? Minus 8, minus 9, 6, 7. You understand now? So that's going to give me minus 56 again, minus 54. You understand now? So that's going to give me minus 56, 54 is equal to minus 2. What do you observe? So you notice that the determinant of M is also the same thing as determinant of its transpose. So what we can conclude adequately here is that when you are finding determinant of a square matrix, then determinant of a square matrix is equal to determinant of the transpose of such matrix. I hope you understand now. So now we were given N as well. So N, let's say the question asks us to find, maybe the second question asks us to find the determinant of N. B, find that N and what type of what? What type of matrix is N? So that is, you have to obtain what type of matrix is N. Don't forget our matrix N is what? 5, 4, minus 10, 8. N is what? 5, 4, minus 10, 8. Let me check again. 5, 4, minus 10, minus 8. Sorry, minus 10, minus 8. Then its determinant is going to be what? Then determinant of N, which is same thing as determinant of 5, 4, minus 10, minus 8. Okay, if you multiply element along the leading diagonal, then I'm going to have what? Minus 40, minus into what? If you multiply those along the what? Second diagonal, that's also minus 40. And this will now give me minus 40 plus 40, which is equal to 0. And what can you say about matrix N? With what I've said, don't forget, when determinant of a matrix is 0, then such a matrix is what? Is singular. Hence, N is a singular matrix. Can you see it is very simple? So M is a singular matrix. If that is clear, let me also give you another example so that you understand it clearly. Example, because you might come across this type of question there as well. The question says, find the value of x, or to find the value of x for which determinant of 2 minus x, 2 minus 5, 1 plus 3x is equal to 0. You understand now? So you have to find the value of x such that this determinant is equal to 0. How do you do it? Find the determinant of this first. The product of those along the leading diagonal, that is 2 minus x, 1 plus 3x, 1 plus 3x, minus into what? Minus 10. That is the product of those along the second diagonal is equal to 0. Then you simplify further and find the determinant of x. So if you expand this is going to be 2 times 3x, 6x, then minus x, minus 3x squared plus 10 is equal to 0. I hope you understand now. So then I'm going to have 2 plus 5x, 6x minus x will give me 5x, minus 3x squared plus 10 is equal to 0. So then if you rearrange it very well, then I'm going to have minus 3x squared, so plus 5x plus 12 is equal to 0. If I were you, I could just multiply through by negative, then I'm going to have my 3x squared multiplied by minus 1 through by minus 1 minus 5x minus 12 is equal to 0. So it has led to a what? A quadratic equation. And how do you do that? Simply by factorization method. Your a is 3, your b is minus 5, and your c is what? Minus 12. So then you multiply this guy by this guy, that's minus 36. Then you now think from the pairs of what? So from the pairs of factors of 36, for each of the number, then there are 2 pairs of number. So such that when you multiply those numbers together, you are going to get the factor. For example, if I have 36, you know the factors of 36 are 1, 3, 4, 9, 12, 36. We can have pairs in twos. We have 136 disappear. So whether you multiply the positive of 1 and positive of 36 or negative of 1 or negative of 36 together, you are going to have 36. Likewise 4 and 9. Likewise 12 and what? 12 and 3. So now think out of this pair, which one are you going to multiply such that you are going to have 36, and when you add, you are going to have minus 5. I think it is this one. That is 4 and 9. You know, when I multiply 4 times minus 9, I'm going to have minus 36. And 4 minus 9 is also going to give me minus 5. Then you are going to replace it with this. Then I'm going to have 3x squared minus 9x plus 4x minus 12 is equal to 0. You can see that minus 9x plus 4x will later give you 5x. Then you now group it like this. You group it this way. So 3s is common. You can take it out. What are you going to have left here? This is going to be s minus 3. Then 4 is also common here. This s minus 3 is equal to 0. S minus 3 is also common. You factor it out. This is going to be 3x plus 4 is equal to 0. And when the product of two numbers is 0, then one of those numbers is equal to 0. Then it implies that s minus 3 is equal to 0, or 3s plus 4 is equal to 0. So then your s is equal to 3, or 3s is equal to minus 4. So s is equal to 3, or s is equal to minus 4 over 3. So if you want to know whether you obtain it, just substitute the value of s to be 3 here. You know, if I put 3 here, so then I'm going to have 2 minus 3, that's minus 1, 2, minus 5, 10. So if you take the determinant, this is going to give me minus 10, minus minus 10, so which is going to give me 0. So that is a singular matrix. So this way I'm going to stop here. If you enjoyed the video, please don't forget to like, share, and subscribe. So till I meet you in the next video, thanks for watching.